graphing linear inequalities of two variables, it's just like graphing regular equations, except for now we're going to have to shade a little bit. And yes, you can do this on a calculator. It'll tell you a little bit better as to what direction to shade, so we'll double check ourselves when we do that. Okay, just a little bit reminder, this is a less than, this is a greater than, this is less than or equal to, this is greater than or equal to, and then we'll have something that says not equal. We won't see that very much. Okay, and then obviously the equal we see, but it's not an inequality, so I'm not going to put it down. Okay, make this little note. Always read from the variable. It makes it easier to graph. So if you have something that is written as y is less than or equal to 3, that's the same as y is less than or equal to 3. Okay? So I read from the variable because when I graph this, a lot of people like to make this little side note, oh, it's whatever direction the inequality is pointing. Well, that's true, but only if the variable is on the left. Okay? So if I always read from the variable, I don't get confused because less is left. I go y is less than or equal to 3. So if when I graph it, I go 3 less than or equal to makes a solid dot, and it goes left, even though the arrow's pointing to the right. When you see compound inequalities is when you see it most of the time. So if I had a y is greater than 5 but less than 2, I'm always reading from the variable. So y is less than 2, y is greater than 5. Okay, so even though I tell you less than is this symbol, you got to always read from the variable. Okay, any questions there? Okay, didn't figure. Example 1. It gives us this equation. Y is greater than negative 3x plus 5. And then it gives you this point, and that's called a test point. Okay, so they say 2, 9. Use that for your test point. And if they give you a test point to use what they give you, but for the most part, the most common one that you will use is the origin, which is 0, 0. Okay? And the reason I say that is because it's the easiest one to use, and it makes life a little bit easier. So try to use it whenever possible. Okay, so when I'm graphing this, since it's already in white equals mx plus b form, we would deal with it the same way. What is my y-intercept? 5. So I'm going to count up 1, 2, 3, 4, 5. There you go, there's my y-intercept. Now, my slope is positive or negative. Ladies and gents, positive or negative slope? Negative slope. So, am I going downhill or am I going uphill? Down. So I'm going to go down 3 over 1. 1, 2, 3 over 1. And I'm good. So I draw my line. So, since it says greater than, is my line going to be solid or dotted? Is it inclusive or exclusive? Remember when we did our dots? It's exclusive, so it's going to be dotted. So I'm just going to go ahead and dot the line as I draw it. Put arrows on either side, and then you run a test point. Your test point is important. So they give you 2, 9 to use as a test point. So let's make sure where 2, 9 is. 2, 9 is somewhere over here. Okay, so it's to the right of our line. So we're just going to run the test point. It's negative 3 multiplied by 2 plus 5. And we have to verify that it is going to be less than 9. So let's start working this problem. Negative 3 and 2 make a negative 6. Negative 6 and 5 make a negative 1. So is 9 greater than negative 1? True or false? True. It's true. So I'm going to give it a little bit of a check mark. If it is true, I shade toward my test point. So since my test point was over here on the right, I'm going to shade toward the right. Okay? Now, I know some of you are OCD and you're going to actually shade the entire thing. That's okay, I don't care. But the only things I'm looking for is that I know which side that you're shading toward and that your line is dotted. Okay? I'm looking to see if you paid attention enough to see if this was dotted and then which side you need to shade on. Now the reason I always say use 0, 0 is because it's the easiest one to plug in. So if you get something that's true, shade toward it. If you get something that's false, shade away from it. Okay? So let's do part B here. That was A, let's do B. B's equation is 3y minus x is less than negative 18. Then it gives us a test point of negative 3, negative 7. Again, I don't care what your test point is, but if they specifically tell you, use that test point. So I'm going to use our little grapher stamper a lot today. I'm going to run this point through. I can either use it graphing the intercepts, or I can isolate y. What do y'all want to do? Intercepts or y equals mx plus b?
Y.
Okay, since the last one was y equals mx plus b, I'm going to go with what I heard, intercepts. So remember how I told you to solve for intercepts? I said set up an x and y chart and stagger a set of zeros. We plug in 0 for x the first time, so I get 3y minus 0 is less than 18. And since this pretty much just goes away, I'm going to divide by 3 right now. So y is, we're going to deal with it like an equal sign, just so you know, is less than 6. So I'm going to plug that in, 6. And I'm going to graph that point. 0, comma 6 is up 1, 2, 3, 4, 5, 6. Plot that point. And I'm going to plug in 0 for y. So 3 times 0 is 0. So 0 minus x is less than negative 18. So since that pretty much goes away, all I have to do is isolate my x by dividing by negative 1. And since I'm dividing by a negative 1, I need to switch the direction of my inequality. That's just practice, because we're just plugging in 18 right there. But remember, when you multiply or divide by a negative number across an inequality, then you have to change the direction of it. All right, so that one's 0, 18. Wow, that's a big one. My graph doesn't go that big, so I'm going to count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, and 18. So here's my point 18. It's okay if you count by 2s, 5s, or whatever, but you have to label your graph to match. Okay? And then I just connect my 2 dots. Since it's an inequality that is not equal at the bottom, I'm going to do a dotted line. It is non-inclusive. Put my arrows, and I run my test point. My test point is at negative 3, comma 7. So negative 3 and negative 7 is somewhere over here. So since my test point is somewhere over here, I'm going to put that into my graph and see if it works out for me. So 3 multiplied by negative 7 minus a negative 3 would have to be less than negative 18 to be true. Start running that. I get negative 21, and I get plus 3, less than negative 18. Negative 21 plus 3 is negative 18. Is negative 18 less than negative 18? No. So I'm going to shade away. Okay? Always shade away. Okay? I did. The test point was down here. Shade on the other side.
So if you make part of your graph by 2, do you have to make the full graph by 2?
No, just indicate. So this one was by 1s. I let it be by 1s.
Okay.
And this one was by 2s, so I labeled it by 2s. But no, you don't have to. You don't have to have matching increments. Not necessarily. As long as you label it to match, be fine. All right, Taylor, to answer your question, it's not always, if it's true, it goes to the right, and if it's false, it goes to the left. That's not how it works. It's, if my test point is here and it's false, I shade away from it. So I would shade on the other side of the line. If it's true, I shade toward it, which is on this side of the line. Okay? All right. Next one. I feel like I messed up something here. I did. Didn't I? Yes, I did. All right. I was wondering if my graph was something wrong with it. Right here, this was supposed to be a negative, so this should be a negative 6. So that messes me up immensely. Either way, your graph still is not going to match. So you'd still shade away. So other than this little mess up, we'd graph everything the same and run your test point the same. Let's do another example to fix that. Alright, so I'm going to do example, where's it at? Example 3B. Okay, example 3B. It gives us an equation that says to graph it negative 2y plus 10x is less than negative 2. Don't lose a negative like I did on the last problem. Since it's in a standard form, I'm going to use intercepts to graph it. So I'm going to use my staggered set of zeros to graph this. Plugging in 0 for x the first time and solving, so I get negative, 0 for x gives me a negative 2y is less than negative 2. Solve it by dividing by negative 2, negative 2. Y then is going to be less than positive 1. Okay. Plug in 0 for y. I'm left with 10x is less than negative 2. Divide by 10. And I get x being less than a negative 1/5. So that one's not awesome to graph, but I can still do it. So I need to graph it. 0, 1 is easy to graph. However, or sorry, that's backwards. 0, 1 is easy to graph up the y-axis. Sorry. 0, 1 is right there. And then negative 1/5 0 is like right there. That's not really easy to see. So, not the best way to make an accurate graph. Okay, so since this is a less than symbol, I need to make sure that it is dotted. It's got arrows. And then I need to run a test point. Since 0, 0 is not on the line, I can only use 0, 0 when it is not on the line. So this is going to be my test point, is the origin. Since it is not on the line, I can use it. So I have 0, 0 plugged into this, and that gives me 0 is less than negative 2. Is that true? Is 0 less than negative 2? No. It's not, right? It's greater than negative 2. So this is not true. I'm going to shade away from the origin, which is to the left. Cool? Yeah, I don't mind. Okay, so the graphing it on your paper is relatively simple. Let me show you how to graph it on your calculator. Get a calculator if you don't have one. Everybody got one? Okay, press the y equals button. We're going to graph, let's do an easy one first. Put y equals 4 into your calculator. Oh, nice. So when we want to use a less than symbol, we have to change this piece, the piece that's right before the y. I think I've showed you guys this once before. It's just a reminder. A less than symbol is the one that shaded the top right corner. Less than shades the top right corner. Okay? So I changed that to a less than symbol. I put in 4. And that should go gray because it's an inequality. Then you graph it, and blam. It shoots across there. No, that's a greater than symbol. Well, the book's backwards, I guess. No, the book is right. Okay, so this symbol is the greater than symbol. Make that in your... I know that you have already done this, but you probably lost it by now if you didn't put it in note cards. This one is greater. That's the greater than symbol. The other one shades the bottom half of it. So this one is the less than symbol. Okay? So if you look at the shaded parts, then it might help. Because remember that the less than symbol so since this is the less than symbol, look at the top part of the square. It makes the less than symbol. And right there, this makes the greater than symbol. Okay, so the part that's not black makes the symbol. Alright, anyways, you can change it in your calculator and you make the graph. You can use that with anything that's in y equals mx plus b form. So let's change it to y equals 3x plus 5. Graph that. You'll see your line jot across there, and it automatically shades it for you. Okay? If we run a test point of 0, 0 here, it would be true. Okay, any questions on how to graph it? Most important thing that you have to remember, if it's just less than or greater than, we have a dotted line. We have a dotted. It's non-inclusive. Okay? If I have a less than or equal to or a greater than or equal to, it's a solid line, and that's inclusive. Okay? Shade according to your test point.